So we'll start with the level 3 problems. The statement of the problem is as follows. So for the sandy soil, which has the spherical grain shape and which is uniform in nature, that means all particles are spherical in shape and all have the equal diameters. So in this case, you are asked to determine the maximum and minimum void ratio. So you have if you have a spherical particle, you know probably the volume of a sphere is nothing but 4/3 pi r cube, or which is nothing but pi by 6 into d cube, pi by 6 into d cube. So both mean the same. So when you have a maximum void ratio, that means the soil is at its loosest state, and when you have the minimum void ratio, that means the soil is perfectly packed at maximum density, or I will call it as maximum dry density. And one more thing here, based on the particle shape and the volume of a cube, you have there are total 14 combination are possible, but out of 14 combination I will just take only 3 combination, and these 3 combination are sufficient enough to in order to determine this maximum and minimum void ratio. So the first case, when you have a simple cube, the arrangement is simple cubic arrangement. So in this simple cubic arrangement, you have got the cube. If I draw it in the 3D, you have got all the lattice points, that is 4 at top, 4 at the bottom, and at each lattice point you have got one particular atom attached to it at all 8 the corners. So these are all 8 atoms at all lattice points. So in this simple cubic arrangement, you got 8 particles at all 8 corners. So that means the total, this particle is nothing but this particle. If I look it from this side, this is 1 by 8, this is 1 by 8, this is 1 by 8. So the total, there is only one particle in the cube. That's what the name came, simple cubic. So there is only one molecule which is present inside a cube, and this is, I have drawn it in 3D. For 2D, if I just view it from a front side direction, I divide it like this way. So I got 1/4 of the particle in this region, 1/4 particle in this region, 1/4 in this, and 1/4 in this. So total we got only the one particle. Remember, this is 1, this is second, this is third, and this is fourth. So total we have got only one particle, or I call it as atom, or you may call it as grain, only one grain which is possible. So the diameter or radius of a grain is denoted by small r, and the cube size is denoted by small a. So the volume of a cube is given by, so volume of cube, which is nothing but total volume. Remember, this is the total volume, which is volume of cube is nothing but a cube. So in that a cube, you have got 1/4, 1/4, 1/4, 1/4. So it becomes 1. So in that you have occupied volume of solid, which is nothing but 4/3 pi r cube, right? So therefore, from a classical definition of void ratio, which is nothing but volume of void to the volume of solid. Volume of void is nothing but the total volume minus solid volume divided by solid volume. So it became total volume divided by solid volume minus 1. So for the first condition, the void ratio here, so for the first condition, you have got this particular type of void ratio, which is nothing but the total volume, which is a cube, divided by 4/3 pi r cube minus 1. this is again rewritten as 1 divided by, or 4 pi. So 1 into, I'll write come 3 into the numerator, 4 pi r by a whole cube minus 1. So you need to establish a relationship between r and a in this case. So it is clearly seen, if it is r, this is also r, so which becomes 2r equals to a. So from this you will get r by a, which is equal to 0.5. So I'll punch 0.5 in this and you will get 3 into 2 into 2 into 2.5 cube. I'll write 1 by 2. So I take 2 into numerator, it goes like this, 2 into 2 into 2 divided by 4 pi. So 2 will get cancelled, 4 will get cancelled, minus 1. So answer will be 6 divided by pi minus 1, and I think you will end up at 6 divided by pi minus 1. You'll get the answer equal to 0.9098. So E, at this case you will get it as 0.91. This is just the simple cubic arrangement. So remember, in this you have got one more factor that is called as a packing factor. Might be asked, packing factor, that means how much volume are going to be occupied by the solid. How much volume are going to be occupied by the solid? That is nothing but the packing factor, or also called as atomic packing factor, APF. So here word attached is atomic packing factor. Maybe asked, packing factor means how much volume is nothing but the solid are going to occupy. So volume of solid divided by the total volume. So total solid volume. So the total solid volume is nothing but 4/3 pi r cube, 4/3 pi r by a whole cube. It is clearly understood from this. So APF for this particular case, for simple cubic arrangement, APF is nothing but 4/3 pi into r by a is 1/2, so it becomes 0.5 cube. This factor comes out to be 0.5236. That means 52.36% of the total volume. The volume is occupied by solids. So this is just the simple cubic arrangement, and E for this is 0.91. We'll again get back to the same page because we still have got 2 more subcases in this, because just now we have seen the simple cubic arrangement where you have only one lattice point at the corner, which indicates 1/4 1/4 1/4 contribution, and this ends at the value of E equals to 0.91, or atomic packing factor of 52%. Second case we got is for the base centered arrangement. So in this arrangement, it will look like quite simpler. We have got a cube of dimension same A, and for this cube you have got 8 lattice atoms at all 8 corners, and we have got another one cube at middle. So this is called as base center. That means one at base is present. So if I just plot it nicely, you have what from 2D, if I looking, then fully you will be getting this particular as base centered, and I've got all the atoms at the lattice point. And if I just get this cross diagonal component cross diagonal component which consists of one R, this is the 2R, and one more again R. So this is the R, this is 2R, this is again R. So we have got along this diagonal, so one, that is a major diagonal of this cube. So 4R will become equal to a square plus a square plus a square under root of all this, so which becomes root 3a. 4R becomes equal to root 3a. So therefore R by a becomes equal to root 3 by 4. Remember, this is only for base centered arrangement. That means the only one molecule in the center of, so you have got one molecule at its base. So this is the relationship between R and A. So there are 8 lattice points, so 8 atoms into 1 by 8, so it becomes 1 and 1 at base. So there are 2 atoms or grains present in this case. So therefore here the total volume will remain as it is, which is a cube. So total volume will remain as it is, a cube. Volume of soil solid will become 2 into 4/3 pi r cube. So this is I think sufficient enough in order to calculate E value. E value is nothing but from our previous discussions, E will be equals to Vt, total volume, divided by solid volume minus 1. So total volume is a cube divided by solid volume 8 by 3 pi r cube minus 1, which becomes equal to 3 divided by 8 pi r by a cube minus 1. So you need to plunge or place this r by a value in this expression in order to get E for the base centered arrangement. So you'll get E or for base centered arrangement, which is equals to, if you take it all the way, you'll end up at E equals to 0.4702 for base centered, and I'll calculate the packing factor for this case, which is nothing but atomic packing factor, or atomic packing factor, which is nothing but how much volume is filled by the solid, which is nothing but for this case you have got Vs divided by, so atomic packing factor is nothing but just the Vs by Vt, and from the definition of E, which is equal to Vt divided by Vs, right, minus 1. That's what we have seen, which is E is nothing but Vt divided by Vs. Atomic packing factor is nothing but Vs by Vt. How much solid are present out of the total volume? So I will just need to have 1 plus E and answer inverse. So atomic packing factor is nothing but 1 plus E and its answer inverse. So you'll get it as atomic factor for base centered cubic arrangement, also called as BCC, equals to 68.02%. We'll again get back to this same page. For simple cubic, you have got equal to 0.91, packing factor of 52.36. Here E got again reduced, and also packing factor got increased, 68. But one more still case was left, which is face centered, subcase number 3. Face centered cubic arrangement. So it is also called as, in short form, FCC. In this face centered cubic arrangement, you have got all the 8 corners, 8 points, similar to the previous case. Plus, in addition to it, you have got one particle at its face. So this is face. So one over here, one over here, one at the back, one at this, and one at the bottom. So you have got total 8 grains at corners, at all corner, and you have got 6 grains at the faces. So this particular face, which is looking at the front side, you have got one particle, and half of it is inside it, and half of which is outside. So therefore you have got 8 into 1 by 8 effective particle 1 plus 6 into 1 half, because for face, the face is shared by adjacent particle, but the corner is shared by 8 particles surrounding it. So that's why here it came 8 and here it came 2. So that's what is your effective number of grains, right? So for this case, effective number of grain becomes 1 plus 3, which is equal to 4. Therefore, same way Vt became equal to total volume, same way which becomes A cube, and volume of soil solid became 4 into 4/3 pi r cube. Remember this 4, very important. Face is shared by adjacent particle, but the corner is shared by 8 particles, so that's why it came formulae. But for base centered, the base atom is not shared, so therefore we just add 1 as it is in that. So but here again, one more relationship for between R and A is left it out. We draw from front side. You have got half of the particle there and half of the particle here. So it looks like this. If I take it just the diagonal, same way R, 2R and R. Here it is A. The cube has got all the way side equal to A. So therefore 4R becomes equal to under root of A square plus A square. So which became 4R equal to root 2A. Therefore R by A becomes equal to root 2 by 4. Earlier it was root 3 by 4 for base centered. For face centered it is root 2 by 4. Therefore from classical definition, E equals to your Vt divided by Vs minus 1. So Vt over here is A cube divided by 16 by 3 pi r cube minus 1. So E becomes equal to 3 divided by 16 pi r by A whole cube minus 1. So E for this case is 0.3505. So for this case you got E equal to 0.3505. And similarly I write it on the fresh page for face centered arrangement. For face centered arrangement, the void ratio, that's what you got it, is 0.35, and atomic packing factor APF is nothing but 1 plus E. Answer inverse is 1 minus 1. It's 74.05% are filled. So I'll write the summary of all this. Summary: first, second and third. First we got the simple cubic, then we have got base centered cubic, we have got face centered cubic, and depending on all this case we have got different values of void ratio and atomic packing factor. For simple cubic, the atomic packing factor is 52.36%, 52.36%, and value of E is 0.91. And for base centered, you got the value of E, which is equals to 0.47 for base centered, and packing factor of 68%, and for face centered you got E value of 0.35 and 74% of packing. You can imagine that if you have a highest amount of packing, you will end up at the minimum void ratio, so this will become minimum void ratio. And if you have least packing, you got maximum void ratio, that is Emax. So therefore, if you have a sandy soil and if the particles are perfectly spherical and uniform in shape and size, that means all particle has got same diameter, same size. So depending on its orientation, we have basically three categories for a simple cubic structure: simple cubic, base centered cubic, and face centered. And depending on these three arrangement, you got the value, that is Emax equal to 0.91 and E minimum equal to 0.35. So that means the sand will have the void ratio in between these two. If the particle size is truly spherical, so not a single particle has got a different size than the other, and all particles have to be uniform, then this relationship holds good, and E generally has to be vary in between Emax to E min. And we have seen also, if you have a natural void ratio even matching or near close to the Emax, then the density of soil, that means relative density of a sand, is nearly 100%. And if you have a void ratio close to E minimum, then relative density of a sand is close to 0% or 0 to 10%. And that's so based on the relative density, we saw the soil description as very loose, medium, dense, and very dense. So and so forth. So this Emax and E minimum, whatever we have derived, are just the based on arrangement of the soil particles in its core volume. Okay, so this is the broader explanation for the level 3 problem, which is 3.1, and we'll go for next problem, that is 3.2. The in situ unit weight of a medium to coarse sand, which is used as a subgrade for highway, was 16 kilonewton per m3, and it was decided to improve this soil by mechanical stabilization. And by doing this mechanical stabilization, we are adding 5.5 kilonewton of the mixture of dry sand and silt into 1 m3 of this subgrade. And then after adding this much amount of soil, which is 5.5 kilonewton, the volume, it was observed that the volume was increased by 20%. And because of this addition of this soil into your sand, volume got increased by 20%, right? So the question was asked that how much will be the reduction in porosity was achieved, because it's just the mechanical stabilization. Mechanical stabilization is meant just for to reduce the volume of voids in the soil, right? And that's what is the definition of the porosity is. Porosity means the volume of voids to the total volume. So how much reduction in the porosity you have achieved is the question that which is asked. Okay, so here just the how much will be the reduction in the porosity of the soil was asked, and also given thing is that GS average for this particular soil is given it as 2.67. So this problem, we have given things is, first of all we have 1 m cube of subgrade, and the density will be 16 kilonewton. And one more important thing is that you have added the dry sand in it, so it is very very important. And also the in situ unit weight is given, and however in this whole question there is no water content and anything cannot be asked, is not given. So you have just given thing is the bulk unit weight of the soil, right? So I'll draw just the three-phase diagram. So first, after addition there will be another phase diagram. So this is the before addition diagram. So we have got the solids and the water. We have got the solids and air. So it is dry. It is sand, that is also given. So the weight, the volume which is given, it as 1 m cube. Total volume given is 1 m cube, and therefore the unit weight which is given, it has 16 kilonewton per m cube. Therefore the solid weight became 16 kilonewton, right? And also the GS is given, which is 2.67. so therefore from this GS we can calculate gamma S, right? Therefore gamma S will now become equal to 2.67 into 9.81, by assuming because in the whole question gamma W is not given, so you need to assume gamma W as 9.81 kilonewton per m cube. So you'll end up at getting 2.67 into 9.81 to get the density of soil solid as 26.1927 kilonewton per m cube, and therefore volume of soil solid, which is nothing but WS, weight of soil solid divided by gamma S, so which becomes 16 divided by 26.1927, which become equal to 0.611 m cube. So the solid volume, get it as 0.611 m cube, and air volume you can calculate by deducting 1 from it, so 389 m cube, so 0.389 m cube. So this is initial phase diagram. So this diagram is initially, or before addition of soil. So once you add the soil, okay, so once you add the soil, the volume was increased. Initially it was 1, but later on the volume was increased by 20%. So in the later on stages the total volume will now then become equal to 1.2 m cube. 20% increase. Initially it was 1 m cube, then it became 1.2 m cube. So just by the addition of 5.5 kilonewton of the dry sand means there is no water content here in this. So initially the solid, whatever 16 kilonewton are there, they has to be there. These are the solids. Then the dry mixture of sand and silt was being introduced, was being mixed with this kind of soil. So it became, this is became sand and silt. This was originally present. This solid was originally present. the solid was originally present. So the weight is 16 kilonewton, and increase in weight is 5.5 kilonewton. So volume is also for solid remains same, which is 0.611 m cube. This volume you need to calculate, and you'll calculate by the same way that Vs for dry sand and silt, right? Dry sand and silt is nothing but 5.5 kilonewton weight divided by gamma s. Gamma s will remain same because that's what GS for all the soil was given. GS average is given rather than GS separate GS for different kind of soil. So this unit weight will remain as it is. So the volume became equal to 26.19. So volume will become 0.21 m cube. This become 0.21 m cube. This become 0.21 m cube. So this is air. This is dry sand. And this is air. So air volume will become, or I call it as rather than air, I call it as void volume. Void volume will be 1.2 minus 0.611 minus 0.21. So it became 0.379 m cube. So this is before, this is after addition of dry sand and silt. So that's how the whole figure came. So for this case, initially you have porosity is nothing but volume of void to the total volume. So initially volume of void is equal to 0.389. This is volume of void. Volume of void means whatever is there except solid volume is the volume of void, which is 0.389 divided by 1. So porosity initially it is 0.389. So after addition of dry sand and silt, the porosity became equal to N2, which is VV divided by total volume. Total volume has increased by 20%, so it is 1.2, but the void's volume will remain equals to 0.379. So it gives 0.379 divided by 1.2, so it gives 0.316. So the in the question, what is asked is the reduction in the porosity. Only reduction is asked. So reduction means N2 minus N1, or mod of N2 minus N1, or N1 minus N2. Positive, it has to be positive number. So it gives 38.9 minus 31.6. 38.9 minus 31.6, it is 7.3%. 7.3% is the reduction in the porosity. Okay, so this finishes your 3.2 problem. But here one more addition to it is further, if 1.5 kilonewton of clay at 10% water content was added, so in the same question, if you add again 1.5 kilonewton of the clay which has again 10% of the water content, then same question, how much will be the reduction in this porosity of soil? But here you need to assume G of clay, the specific gravity of soil solid for clay is 2.55. So for the same question, after addition of 1.5 kilonewton of clay, what will happen? So this is first case, this is second after addition of dry sand and silt. So in the third stage, I'll again draw the second and third in order to have clarity. So in the second we have solid, we have dry sand and silt, and we have air, and the total volume was 1.2 m3. We have solid, right? So this is 5.5 kilonewton, and this is 16 kilonewton. So everything is being the same. So in this, by considering all volume will remain same, how much will be the reduction in porosity? So in this case you have got N2, which is equals to 31.6%, and here in this case further 1.5 kilonewton of clay is been added without change in the total volume. So further addition will be 1.5 kilonewton of clay at 10% water content. I'll draw a separate diagram for just only the clay. I'm drawing 1.5 kilonewton of clay. This is 1.5 kilonewton of clay. So it is only clay, which consists of water, which has 10% of water in it. The total weight is 1.5, right? So the weight of the clay plus weight of the water will become 1.5. This is water, this is water, and this is the clay. Total weight is 1.5. The percentage of water, that is water content, in this case is 10%. That's what is mentioned in the given problem. So weight of the clay, WC plus WW, will become 1.5, and one more expression for water content, which is 10%, nothing but weight of water to the weight of clay. So with the use of these two equations, I calculate the weight of clay and weight of water, and for that WC plus, I replace WW by 0.1 WC. Therefore you get WC it as 1.5 by 1.1, 1.364 kilonewton. So this much will be the clay, 1.364 kilonewton, and the water will be rest 1.5 minus 1.364, which is 0.316. This is 0.136 kilonewton. This is water. Okay, and corresponding volume of the clay will be VC. VC will be WC divided by gamma C. So VC became equal to 1.364 divided by gamma C is nothing but specific gravity of clay into 9.81. Specific gravity of clay is 2.55 into 9.81. So you'll get this volume in m cube. Divided by 1. It became equal to 0.05453 m cube. it become 0.05453 in m cube, and water is just 0.316 or 0.136 divided by 9.81. It is 0.1386 m cube. So this is in m cube, the volume of clay. So in order to determine the porosity, you need to place this whole thing in this. So after placing this clay, this is clay, right? And this is water. This is water. After placing I'll write volume. Sorry, over here weight of the clay is 1.364 kilonewton. Weight of water is 0.136 kilonewton, and weight of air is absolutely 0. So I draw again the modified diagram. This is dry sand. If I draw the whole complete holistic diagram, it looks like this. Alright, volume onto this side. We have 1.2 m cube volume, and then we have a solid volume which is equals to point. This is solid initially present, volume of solid 0.611 m cube. Then we got dry sand and silt, volume of which is 0.21 m cube. Then we got clay. The volume of clay is 0.05453. 0.0545 m cube, and rest of the thing apart from this clay will go into the void. So this is void, which includes even the water as well. This is water. So this particular volume is 0.1386 m cube, and rest of the thing is air. Air volume is also, which is equal to 1.2 minus all this addition, 0.611 plus 0.21 plus 0.0545 plus 0.01386. So this is what the volume of air is. Therefore the porosity in this case, that's third phase, N3, is nothing but volume of voids divided by total volume. So it becomes volume of voids is nothing but air void plus water, volume of water. So this is volume of air, VA, which is 1.2 minus 0.611 plus 0.21 plus 0.0545 3 plus 0.0386. So volume of air is 0.3106 m cube. So void volume will be 0.3106 plus 0.01386 divided by 1.2. So answer plus 0.013. So it becomes N3, porosity becomes equal to 0.27 0.04, and therefore the net reduction from N2 will be equal to, from N2 you have got porosity equals to from N2 you have got porosity of 31.6%, right? So 31.6, which is 31.6 minus 27.04, I think it is 5 or 4 point something, yeah, 4.5%, 4.56% from N2, the net reduction. So we just now discussed the problem number 3.2, and we have evaluated the porosity after addition of the 1.5 kg of the clay. So we'll now begin with the new problem, which is problem number 3.3. The statement of problem is as follows: the liquid limit of the clay is given it as 50%. Plastic limit of the clay is given it as 25%. And there are the two statements which was given. The first statement states that when the soil was dried from its state at liquid limit, then the decrease in volume was 40% of the volume at liquid limit. And when the soil was dried from its state at its plastic limit, the decrease in volume was found to be 20% of the volume at plastic limit. So this two wording found to be too confusing, right? So but I'll try to make it as simpler as possible. So when I'll draw it in graphical way. So same diagram. I got this dry volume and then the rising. You have solid, semi-solid, plastic and liquid phases, and this is the liquid limit, this is plastic limit, and this is shrinkage limit. So in the problem, this liquid limit is given it as 0.5, plastic limit given it as 0.25, and it's in the first statement it was said that when the soil was dried from liquid limit. So when it is dried from liquid limit, suppose the volume at liquid limit is VL. So when the soil was dried from its liquid limit, the decrease in volume was found to be equal to 40% of the volume at liquid limit. So the decrease in volume, here also the second statement, decrease in volume. So the decrease in volume, that means from this point to this point, the volume decrease was found to be 40% of the volume at liquid limit. So 40% of the volume at liquid limit. So that means 0.4 times VL. First statement. Again I'll repeat. At liquid limit, whatever volume is there, if you dry it from this particular volume, then the decrease in volume was found to be a 40% of the volume at liquid limit. So that means the decrease, that means from this point to this point, because the soil cannot have a volume less than the dry volume, that is VD. So therefore the decrease in volume was found to be 0.4 times its VL. So we don't know this volume at liquid limit, and also we don't know this VD. But in the second statement, the given thing is that when the soil was dried from its state at its plastic limit, the decrease in volume was found to be 20% of the volume at plastic limit. So therefore, when you dried from this particular plastic limit, then whatever volume is there at the plastic limit, so this decrease was found to be equal to the 0.2% of the volume at plastic limit, VP. So this decrease is found to be 0.2% of the volume at plastic limit, and this decrease when the soil is dried from its state at its liquid limit, this decrease was found to be 0.4 VL. So, and the asked thing, the quantity that you're asked is to evaluate the shrinkage limit and shrinkage ratio. These two things are asked. So again, go on, we will proceed ahead for the statement of the problem. VD will not change at all. Whatever change once you dry the soil will the total volume from this state to this state. So even if you go on drying soil, the volume will not change after its shrinkage limit, right? So therefore, first case, we have this much of VL. So this is VL total. This is VL, and this is VP. From this to this, this is VP, and from this to this is your VD. I hope you're clear with the definition. From this point to this point is the volume at the liquid limit. At the liquid limit. From this point to this point is the volume corresponding to water content at plastic limit. And this is the dry volume. So the soil cannot have the volume less than this particular volume. So therefore, if I just concentrate on the first set of the equation, that this to this is 0.4 VL. If this is VL, then this has to be equal to 0.6 VL, right? Because this is total VL and this much is the 0.4. So 1 minus 0.4 VL is 0.6 VL. So first statement states that VD is equal to 0.6 VL from first statement. From the second statement, when you dry the soil from the state at its plastic limit, this particular reduction in the volume was found to be a 0.2% or the 20% of the volume at plastic limit. So if this is 20%, then this has to be 0.8%, 0.8 of VP, because the total has to be equal to VP. So therefore, from statement 2, VD will become equal to 0.8 VP. So if I compare this equation 1 and this equation as 2, and I'll try to establish a relationship between the volume at liquid limit and the volume at plastic limit, I'll get it as follows. So VL will 0.6 of VL will become equal to 0.8 of VP. So from this you'll get VL or VP by VL equals to 3 by 4. VP by VL equals to 3 by 4. So that's what you'll get it from these two statements. Interpretation is very, very important. So again, you're very close enough to find it out, the shrinkage limit. So you see, I need to find it out the slope of this curve in order to calculate WS. So this particular volume, when it was decreased, this particular decrease in volume is 0.4 times VL, and correspondingly the magnitude in between, suppose liquid and plastic, it was 0.25. So if I just want to calculate the slope of this line, I'll just write it over here as slope of this line S is equals to the change in the vertical ordinate, which is nothing but the VL minus VP, right? Which becomes VL minus VP divided by the liquid limit minus plastic limit. So this is volume at liquid limit minus plastic limit, that is vertical ordinate divided by horizontal ordinate, liquid limit minus plastic limit. So it becomes equal to 0.5 minus 0.25 and VL by VP. So I'll replace, I'll make it in terms of dry volume VD. So VL, I'll replace it by VD by 0.6. VD by 0.6. I'll replace VL by VD by 0.6. VD by 0.6 minus, I'll replace VP equals to VD by 0.8. VD by 0.8. So 1 by 0.6 is 1.667. 667 times VD minus 1 by 0.8, which is 1.25 times VD divided by 0.25. So it becomes equal to 7 minus 1.25 divided by 0.25. It becomes equal to 1.667 times of VD. That's what is the slope of this line. Okay, so from this is the slope of this line. Now I need to get it. So if I just go down by 1.667 times of VD, then horizontal will be shifting it from 0.25 amount. So I'll consider this as origin. So I have moved down for a distance of equal to so from this point I moved down to a distance equal to this much amount, 1.667d VD, 1.66. Then I'll get it this particular ordinate. So how much I need to move is 0.4 times VL. 0.4 times VL is nothing but how much time VD you need to move. So 0.4 times VL you need to move. So VL I need to again place VL equal to VD by 0.6. VD by 0.6. So you need to go at distance equal to 0.66 times of VD from that particular distance. So from this again you need to go down equal to 0.66 times VD. Then how much abscissa you will get, which the x ordinate is nothing but your horizontal distance. Right, the new page. Horizontal we moved from horizontal we moved from this point equal to 0.25. So I need to move the horizontal distance from this particular origin to 0.25. So from this origin I moved 0.25 horizontally, then vertically I moved equal to this much, right? I need to move this much, but this much is nothing but VL minus VP. So therefore vertical distance, so in order to calculate this vertical distance, this VP, this is total is VL and this is total is VP. So VP is equal to 0.75 times VL, right? So this much ordinate is 0.75 times VL. So right pen, this much ordinate, this much is 0.70 times VL from this particular expression. VP equal to 0.75 times VL. So this remaining vertical distance therefore has to become equal to 0.25 VL. So therefore you need to move down by 0.25 VL. 0.25 VL. So if I go by horizontally 0.25, you need to go down by 0.25 VL. So therefore this particular amount is 0.2 VP. So 0.2 VP is nothing but equal to this amount, 0.2 VP. So in terms of this expression, VP is nothing but 0.75 times VL, right? So therefore 0.2 VP, if I again need to go back from this particular point, so 0.2 VP, I need to go down from this point. So it become 0.2 VP becomes equal to, write it on fresh page, 0.2 VP will become equal to 0.75 VL into 0.2, which gives you 0.75 into 0.2, which gives equal to 0.15 VL. So this will be equal to 0.15 VL vertical ordinate. So if I go it down from this to this 0.15, then vertical distance is 0.15 VL, so this has to again become horizontally to 0.15. So from this point you need to again move by 0.15. So already you have 25%. This is 25%. This is 25%. This to this is 25. And from this 25 you're again moving here in 0.15. So therefore WS becomes equal to, from the figure you have 0.25 minus 0.15, which gives equal to 10%, or I'll write 0.1. The shrinkage limit will be equal to 10%, right? Therefore first case of WS is over, which is equals to 10%. But to determine shrinkage ratio, what is shrinkage ratio? I have already defined. So the shrinkage ratio is nothing but the slope of this line divided by VD. Shrinkage ratio is nothing but slope of line divided by VD. We have defined this line, this slope, theta divided by VD, and we have calculated slope of the line in our previous discussions. Slope S, we have calculated slope S as 1.667 VD. So shrinkage ratio will now then become 1.667 VD divided by VD. So it becomes shrinkage ratio equal to 1.667. So this finishes your all the level 3 problems in the index properties of soil. Thank you.